Okay, you're all welcome to this section of chapter 4. So we have some set of questions and let's have a quick run through of them. First, the diagram shows part of a water cycle, and the arrows here represent movement of water. So obviously here you know this is precipitation. The water is coming in, and water going out from lakes are evaporation, from plants transpiration, um, from land and from ocean also going back to the atmosphere is evaporation. Flowing on top of the earth's surface is surface runoff, and when it moves down, this is infiltration taking place, and here is groundwater flow, and this should be subsurface flow. um, then X here should be the groundwater store or an aquifer. Then Y here should be the infiltration, and this will be still the groundwater flow that will take it back to the ocean. So the first question is state the water store. So X is an aquifer, or if you remember the ground, if you can't remember that, just remember groundwater. Then Y there is infiltration, the movement of water into the so now name two different types of precipitation. This can include rain, snow, we have hail, we have we have all these are examples of precipitation. And here I said that the photograph shows a child collecting water and to drink in an LEDC. So the first question is state two reasons why this water is unsafe for drinking. Now it's unsafe because first, look at the child. The child is standing in the water. That doesn't make it safe. Standing in the water. Another thing, you see there are debts here. So you find out that the water is actually polluted. So no, this water can contain toxic chemicals washed from farmland into it. So just get two concepts from there, you're good. Now they say describe two ways supply of safe drinking water could be provided to this area. That's first, you should have proper sewage treatment. Things like boreholes can be made available. Things like local wells can be made available. Another thing is you can do is you create desalinization plant. Should also be done to treat water and supply it. And then you have rainwater can be harvested. Or this will go a long way. Then next is they say the scientists investigated the impact of water quality on female life expectancy. Life expectancy here is the average age an individual is expected to live before in a country before they die. So calculate the percentage increase in female life expectancy if there is a supply of safe drinking water. So safe drinking water life expectancy increased to 82.6 minus 72.9 divide by 72.9 times 100 will give you answer. This is new. I normally call it the new minus old value over old times 100. That's how you calculate percentage increase. So just two reasons why some countries do not have sufficient access to safe drinking water. Now, this can be because of economic reasons, and example of economic reasons are things like when there is no investment in sewage treatment, they don't have sewage treatment, no reservoirs available. Then another thing that can lead to this is economic scarcity, you can have things like physical scarcity. Physical scarcity can be lack of rain or lack of precipitation. It can also be that there is no sufficient access to safe drinking water. Two reasons. Now, another reason can be that um, there is increase in population also can lead to this. Now, the next question is, we have the map shows the predicted availability of water in different countries in 2025. Some countries will be water rich while others will be water poor. Okay, so this represents the water rich. So if you check your key, and this is water poor and this is no data. So first, I said describe the predicted distribution of water-rich and water-poor regions in 2015. So if you look at this, you find out that this is Tropic of Capricorn, this is Tropic of Cancer, this is the equator. Now, the whole of Africa and Oceania is water-poor. First, I'll come down. Africa and Oceania are water-poor. Another thing, Tropic of Capricorn are water poor. You come North America, Europe, and Northern Asia is water rich. So I have things like North America, Europe, and Asia. Northern Asia is water rich. Now, most part of South America, except the southern part, is, and also if you draw your cardinal point, they should be the northwestern part, are also water rich. That's all. Now, suggest three reasons why countries may be water poor. They can be water poor when supply. You can say you are water poor when the supply of water does not meet the demand. You are water poor. Now, if you look at it with reasons for water scarcity is quite similar, and things like when you have economic reasons, which I explained earlier. You can have some physical reasons why you are water poor, which I've explained earlier. So physical reasons like lack of rain, when supply does not meet demand, you can also suffer from that. Let me see, that's question number what? Okay, 7. So when you have limited precipitation, and that's a physical reason, lack of rainfall. Reason for water scarcity, when you have economic reasons, we mentioned that when demand for use is greater than supply, and supply does not meet demand. So you can have geographical reasons. You can also have unable to capture precipitation. So reasons for water scarcity, water cannot be made available in the country, and things like also included droughts. So all this can lead to water scarcity within a region. Now, quickly, they say the map shows the area of the world where cases of malaria occur. So we have malaria cases around the equator. All of them have malaria cases. But this area that have water available, northern hemisphere, don't have malaria scarcity, and also the Oceania. Now, use the map to describe the change in distribution of malaria cases from 2000 to 2016. So these areas have malaria in 2000, but they don't have in 2016. So the changes that occur, describe the change. So it's simple. Um, so you find that Africa, malaria cases. So the whole of Africa have malaria in 20s. Most part of Africa, except areas within the north. This is northeastern part here. Do not have malaria in 2016, but majority of Africa have malaria in 2016. In 2016, you find out that North America, Europe, and the north of Asia and Oceania do not have malaria. Then you find out that in the South American continent, there was a decrease in malaria cases because the southern part have malaria as of 2000, but as of 2016, the southern part doesn't have malaria anymore. It's only the northern part. So, quite frankly, those type of questions is just say what you can see. Now, state three method used to control malaria. You use anti-malaria drugs. Anti-malaria drugs. Another way, you make sure you have know you anti-malaria drugs. You use things like nets. Um, you use pesticides, or sorry, insecticides to kill malaria. And there is this insecticide, and you make sure there is no stagnant water to allow malaria breed. Stagnant water are removed. So there will be no breeding places. All this can help to control the spread of malaria disease in an area. So let me see. Um, you see, reduce in 2016, reduce in southern and northern areas, name area, continent, blah blah blah. Anti-malaria drugs, mosquito net, control vector, mosquito with pesticide, remove stagnant water, application of oil on water. So next will be, they said a scientist said there were 445,000 deaths due to malaria in 2016. 80% of these deaths occur in 15 countries. Calculate how many deaths from malaria occurred in these 15 countries in 2016. So it will simply be 80 over 100 times this total, which is 445,000. If you do that, give your answer. Now, suggest reasons why it is difficult to control malaria in some countries. In some countries, you find out that there will be lack of money to buy malaria net. So you see, first is remoteness of the population, lack of money to control for any particular control method. So lack of money to get insecticides. There is lack of money to also get insecticide, malaria nets, and the rest. So remoteness of the population, then lack of proper health care within the region, lack of awareness among the population, and resistance to malaria drugs. And if you have lots of stagnant water, all that will make it difficult for a country to control malaria. So simple. Let me see. They said, okay, there is something I need to still explain. There is this question that came out, and where they ask you to describe, I think they said describe the life cycle of malaria parasite. See, it shouldn't be something difficult because I've seen it in some textbooks, and describing that is really, really quite difficult if you're not properly into science. But see, once you're asked that question, first you can say, if they say describe how malaria spread, or possibly they can actually describe the life cycle. They say how malaria spread in an individual. First, it moves from now. You can be bitten by mosquitoes, and as a result, if the mosquito carry the parasite, you get infected, and the parasite gets into your bloodstream, and it's matured in your bloodstream, and over time you fall sick from it. And if it gets to a significant level, and also if you take the drugs, you can actually kill it because it multiplies majorly in some part of your liver cells. So you should take note of that, and study it, because I feel it might come out in the exam. Now, cholera is a major water-related disease which causes large number of deaths in less economically developed countries each year. Now, providing people with safe drinking water help prevent cholera. Yes, so describe how cholera spread. Is spread from one person to another. So simple. Now, if you drink contaminated water, you tend to have the parasite. You tend to have cholera. And when you also defecate, and it flows into water body, and that same water is consumed by somebody else, the person can become infected also from cholera. So quickly, you see, let's look at that. Say cholera is caused by bacteria. Yes. Person infected with the bacteria. Sewage from infected person leak into water. Yes. Water supply is contaminated. People drink water, then the person will obviously get contaminated. So first, and this cholera bacteria, it's caused, sorry, cholera is caused by a bacteria. It's caused by bacteria. Now, so if someone is affected and he defecates, and the water and is washed into water body, and the water is not treated, water or the sewage not treated, then someone else consume the water. Someone else consume the water. So that person becomes infected. That's all. Now, they said the table shows the percentage of the population of 10 countries in Africa with access to safe drinking water in 1990 and 2015. Now, they say calculate the average. The average, you total everything here, divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you total everything, divide by 10, we give you the average here. So simple. That's 1 mark. State the country that had a decrease in access to safe drinking water. So a decrease in access to safe drinking water. Blah 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 blah. Let me see a value that is. This is increase. This is increase. A decrease. Zimbabwe. It decreases by 2. So you come write Zimbabwe. Now, the lowest access to safe drinking water in 2015. The lowest access to safe drinking water in 2015, the value that is the lowest here is 49. That's Angola. The largest increase in access to safe drinking water from 1990 to 2015, the largest increase. This one you have to, the largest increase here is just 47, I mean 42, 49. That's the increase here. I think it's 7. Here the increase is 4. Here 57, 13. I have 4, 4. Here's 44. Here the increase should be 89, 56. I have 3, 3. This is 33. Here 43. That will give you 47. Here I have, here I think it won't be up to that, it won't be up to that, it won't be up to that, it won't be up to that. So the answer is Malawi. Now they say explain why access to safe drinking water is important. So access to safe drinking water is quite important because it reduces the spread of cholera, so it reduces for health issues, and water is also a necessary component for every living organism. So let's just have a quick browse through because okay, got that. Now it causes diseases. Name of diseases: cholera. You'll be unable to walk. No food for the family because water is needed for agriculture. People will die from it, lead to dehydration. Clean water is basic human need. So simple. First, they said it's a basic human need. But you see, you can use multiplier factor here to get the full answer. Lack of access to safe drinking water, it causes diseases such as, it causes cholera. Now you use multiplier factor. If it causes cholera, what will happen? The impact of having cholera is that people will die. And if people die, the impact is they won't be able to walk. They will not be able to walk. So just walk around that, you get your full mark. Now they say the graph shows global water consumption by continent from 1970 to 2015 and predicted to 2020. So 1970 to 2015 and now predicted. So this part is the predicted ones. So you check your key: actual water consumption and predicted water consumption. So the first question is state the water consumption in Europe in 2010. So you come, where is Europe? World. This is Europe. Which year? 2010. This is it. So you trace it. I think that should be it. Yeah. No. This is it. This is it. No, the column ahead. So this is it. So this is 500, 6, 7, 8, 9. You now have 1000, so it's 600. Now they say compare water consumption in Asia with that of North America from 1970 to 2020. So Asia with North America. The water consumption in Asia increases from 1970 to 2020. So the water consumption in Asia is is more than that of North America. So you can use statistics. In 1970, Asia was around 1,500, while North America is around 550. Remember to put your unit, which is billion meter cube per year. From 2015 to 2020, the water consumption in North America is constant, while in Asia keeps increasing also from 2015 to 2020. You write that, you get a full mark also. So that's it. Then they say calculate the percentage of the world's water consumed in Asia in 1990. Calculate the percentage of the world's water consumed in Asia in 1990. Circle your answer. So what is the volume consumed by the world in 1990? This is 1990, so you trace it up. This is for Asia and this is for the world. So for Asia, they consume blah 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 2000. So Asia in this case is 2000, while the world is 3500. So to calculate the percentage consumed in Asia in relation to the world will just be 2000 divided by 3500 times 100. You get your value here. Now the population of Africa in 2015 was 1.25 billion. Now use the figure. Let me clean this so that you see it well. 1.25 billion. Use this figure and the graph to calculate the average water consumption per person in 2015. So let's look at 2015 again. In Africa now, 2015 is this is Africa here. So this is 100, 200, 300 billion. So you have 300 billion per meter cube. So if it is in 2015 you have 300 billion, so it will be 300 divided by per person. Now it will be 1.25, because you get all of them are in billions, so billion cancel billions, you divide, you get your answer. Now they say explain why global water consumption keep increasing. The major reason is there is increase in population. Another reason there will be because there's increase in population, there is increased demand for food, so water will be used in agriculture. Increased demand for food, so more water for irrigation. Agriculture, you can put irrigation. Now more water for domestic use, i.e. washing and bathing, washing, drinking, and to bathe. Then more water will be used for industries, used in industries. All this will give you a full mark. Now they say describe how human activities in towns and cities can pollute water. First you have things like in towns and cities you have can pollute water. So improper sewage disposal, when you have improper refuse dump, all this can be washed into water. Now areas where you use fertilizers can be washed into water. Then industries, industrial waste dumped in water body. All this can pollute water in cities. Let me see the mark scheme so we can actually get more of that content. Okay, so increase in population, increase in wealth, increase in industrial expand. Okay, in domestic, okay, water supply, okay, would have been shocked. Now, water from factories enter water courses, waste enter into ground, untreated sewage, oil from vehicles, human domestic rubbish, in floods, pollutant wash into water, lack of waste management, acid rain, changes the pH. Okay, there is no what is it called, fertilizers here, because fertilizers I think will this will fertilizers will be for this will be for majorly think when you have rural areas, not around towns and cities. So you can have things like oil spillage from can also pollute water. So good. So water pollution is more serious problem than enhanced greenhouse effect. How far do you agree with this statement? Um, when you see they said water pollution, there are two statements here. Water pollution is a more serious problem than enhanced greenhouse effect. Now, I've explained this. When you answer this type of question, you look at first, you must look at the two sides of the argument. Two sides of the statement must be, you must write about it to get your full, I think this should be a 6 mark question. Yeah, said it. Constructive argument, and you can also give examples. Now, impact of, you should know the problems associated with water pollution, and those can include things like look at people health, which we've stated earlier. It can lead to death. You look at disease that will be spread as a result of it. You can, so that's a serious problem. You can, that can reduce, the workforce of that country. Now, if you look at greenhouse effect also can lead to global warming. When you greenhouse gases into the atmosphere, that can lead to climate change, and climate change here can also cause things like you can have flooding. If part of global warming is increasing global temperature, that can lead to things like cancer. So it also affects health and the rest. So you argue from two sides of the argument. You write from two sides. So you constructively argue about the two, and you now come to a conclusion about which you feel. So you link it back to your question, and so there is, everybody can have a different conclusion, but the basic thing is you make sure you argue from these two different perspectives about the impact of those two phenomena. Now, they say the pie chart represent all the water on earth. Okay, use the pie chart to calculate the total percentage of fresh water on earth. Here, frozen water, seawater, available fresh water. So, but they say the total percentage of fresh water. This is fresh water, but it's frozen. So, available and fresh, that's 2.5 plus 0.5, that's 3%. Your answer here is 3. Now, state two sources of fresh water. You have rivers, you have glaciers, you have rivers, glaciers, you have your wells, boreholes, or sources of fresh water. Now, suggest how the availability of fresh water may change as the population of the world increases. As the world population increases, there will be more demand for water for domestic use. There will be more demand for water for industrial use. There will be more demand for water for agriculture, just like functions for that we answered earlier. The uses of water, uh, because of increase in population, the use of water will also increase in those aspects. So as a result, you find out that the amount of fresh water available will also decrease, and increasing population will also lead to pollution sometimes of these major water sources. So that's an effect. don't think I need to answer that because of time. Let's see. Okay, these are sources of fresh water: desalination plant, rain, reservoir, rivers, well, lake, aquifers, oasis. Now, greater consumption by people used for industry, pollution of water sources as population increases, also global warming, temperature rises, greater evaporation, and climate change due to less rainfall. All this will reduce availability of water if population increase. But you see, the water source can also increase due to technological advances, melting of glaciers, and also things like technological advances like when you have desalination plant and reverse osmosis. All this can lead to either reduce water or increase water as population increases. So any three from more demand for drinking, therefore more agricultural use of water. What am I even answering? Which question is this? Question number, okay, I told it as two. Okay, okay, this is what we are looking at. So let's move to the next one quickly. Question number, now they said in 2020 over 2 billion people did not have access to safe drinking water. By 2050, now the world population is predicted to increase by 2 billion people. Suggest why increase in population will affect access to safe drinking water. That question and this question is the same thing. So usually the same format you answer it. So if you look at the mark scheme, you find out that more demand for drinking, that's domestic use. Food, therefore, they need water will be used for more agriculture. Water will be used for more industries. People will use, give example of domestic use of water, like showers and pools. More industries because of therefore more pollution. Because as you have more industries, there'll be more waste and there'll be increase in competition. So all that will affect the access to water in these locations. So this question and that question is the same thing. You just need to know how to interpret it. Now, water samples are taken at three locations along a river. Now, they say state the location of the water sample with the lowest concentration of iron. Now you have concentration of iron. State the location. So location 1, location 2, location 3. Which one have the lowest concentration of iron? Location this have the lowest here. It has 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 the lowest here. No, it has the lowest with this, and this is similar. So, but this, so my answer will be location 1. It's quite obvious. Calculate the range in concentration for potassium. Calculate the range. Okay, range here is the highest minus the lowest. So for potassium, this is potassium, the highest is 11.8 and the lowest minus 2.6. That will give you the answer. Now at one of the locations, the river flows through a farm that uses fertilizers. State which location. Explain your answer. In one of the location, it flows through a farm that uses fertilizers. Fertilizers majorly are NPK. So they are nitrogen, which is nitrate, potassium, and phosphorus. So the ones that have the highest concentration of nitrate, phosphate, and potassium. Highest concentration of nitrate is this. Highest concentration of phosphate is this. Higher concentration of potassium is this. So location 3 uses fertilizers. Location 3, reason they have the highest percentage of nitrate, phosphate, and potassium. That's the answer. Let's see. Maybe I'm wrong. Location 3, NPK. Told you. That's it. So, suggest building a dam is the best way to provide a constant water supply. To what extent do you agree with this statement? So this is an argumentative essay. So the first thing you need to look at is you look at the advantages of a dam, and but you don't you also, to what extent you look at the advantages of a dam. It helps in provision of water. You can have a treatment plant close to a dam, and you can have reservoirs. So during period of lack of precipitation, water can still be available for things like for distribution. So they can have a reservoir. You can have a dam also. So the reservoir will help to store during lack. So a dam can, the water can actually be treated before distribution. So you can have a sewage treatment plant close to a dam. That's an advantage. However, you find out that a dam also have several impact on the environment and the ecosystem at large. So it can disrupt the food chain within that water course. It can lead to displacement of people for construction. So you look at that, the dam can collapse, leading to flooding. So these are things you just use while having a coherent argument. So you see the response here, a coherent response is given, therefore develop and support the candidate conclusion using relevant details and examples while you answer that question. And the content is you either no response or no, okay. Here you either agree it dam. So when you agree, you put at the advantages of a dam. You disagree, you look at the disadvantage of a dam. So not that you should just say you disagree. No, you should look at it from two aspects. You should agree, and there should be, you should be able to construct that you put some of the disadvantages of a dam also. So you see, agree is one, you can use a dam to produce HEP. Now, if you look at that, they say building a dam is the best way to provide constant water supply. Now, what most students will get confused here, for a 6-mark question, they will just want to answer this in relation only to the importance of dam in water supply. No, you should look at the general importance of these major keywords. Keyword here, which is the dam. So a dam is used for HEP. It helps to store water to prevent flooding, but if it breaks, it can also lead to flooding. Now, it's a source of water supply. Did you get that? Now, it provides habitat for fish. Also, some species might also die. That's a disadvantage of it. It can also affect the food chain. Now, provide recreation such as swimming, provide water for irrigation. Now, we provide jobs for the building and the maintenance process, income to the local people, fish tourism and recreation, and tourist attraction. So that's it. But the disadvantage is expensive to build, and they need massive engineering need to undertake. So you spend more money in the process. It requires dislocation. So you see, people can now, we have to leave the areas because of flooding of their properties can also occur. Geology, not always suitable because it needs a very good strong bedrock for the dam to stand. Now it's susceptible to earthquake and also terrorism, damage the environment or the habitat, destruction of fish, so fish migration. It require cost of maintenance. Silt can build up, reduce availability of water downstream, and also causes cross-border conflict in terms of the several regions that water need to pass through. So if you're able to structure your answer, so anytime you're given this type of question, you should look at it from two different perspective of both the, when you agree and you disagree, you have a constructive argument about it and to buttress your own point, then you get your full 6 marks. Okay, thank you, and good luck in your exam.